Hi, welcome to lesson 10.2, Finding Arc Measure. So today's lesson doesn't have much of an exploration, but there is quite a bit of vocabulary that we do need to know. So bear with me, there's quite a bit of vocab. So we are on page 283. Okay, so make sure you guys are at page 283. So our first vocabulary word that we have is called a central angle. Okay, a central angle of a circle is an angle whose vertex is the center of the circle. A circular arc is a portion of a circle as shown below. Okay, so a circular arc is only a piece of the circle, not the whole part. Okay, or a piece of the circumference, you would say. The measure of a circular arc is a measure of its central angle. So right now we're referencing to the arc measure, not the arc length. We're going to get to that in the next couple of lessons. So the actual length of this is called the arc length. But right now we're talking about circular arcs and their arc measure, which is the same as the measurement of the central angle. Okay, so the measure of the circular arc is the measure of its central angle. If the measure of the angle is less than 180, then its circular arc is called the minor arc. And of course, if it is bigger than 180, then we call that the major arc. All right, please turn to page 284. We are not doing anything on this page, so just go ahead and put a little X on that. And let's go to page 285. Now on page 285, please make sure you write down where the problems are going to go. 1A, B, C, 2A, B, and C. Now down here, we have the measure of the minor arc. So let's talk about that. The measure of the minor arc is the measure of its central angle. That's something that we just spoke about in the part of the exploration. So the expression, the measure of AB is read as the measure of arc AB. So a little bit of notation. So the measure of arc AB, it has AB with a little line on top. Let me zoom in a little bit. Okay. So in this example here, this is the measure of a minor arc, and its arc measure is 50 degrees because the central angle happens to be 50 degrees. Now the measure of the major arc, that is the one that is of course larger than 180 degrees, would be this one, would be the difference between 360 and 50 degrees. So 360 take away 50, that gives you 310 degrees. So the measure of a semicircle, okay, this is a very important part, a semicircle is 180 degrees because it is half of 360. Okay. Page 286. All right, so on page 286, we're going to do 3A here, 3B here, 3C, and 3D right there. And then here at the bottom, we're going to have 4A, 4B, and 4C. Now, let's go up here and look at some of these postulates. Now, this chapter is not really heavy on proofs. Actually, there's not really much proofs to do. So we're going to kind of try to go away from that. So I want to explain what each one of these theorems says. Okay, the first one, the postulate, arc addition postulate. The measure of one arc is formed by the two adjacent arcs is the sum of the measures of the two arcs. This is kind of like the segment addition postulate, but for circles. In other words, if you add this segment AB and this segment BC, that would be the equivalent to the measure of ABC. Okay, it's very important that we use the three letters because if we just say AC, well, are we talking about this one or are we talking about this one? So it's acceptable to have three letters in the notation. All right, here's our first theorem. Two circles are congruent circles if and only if they have the same radius. And it makes total sense. If they have the same radius, that means that they're going to have the same area, they're going to have the same circumference. So they're pretty much going to be congruent. So this is a notation for congruent circles. Circle A congruent to circle B, if and only if the radiuses are the same. AC congruent to BD. Here's the next theorem. In the same circle or incongruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. This is like cutting up a slice of cake right from the center, going by, doing two diameters. So if these two central angles are the same, then these two measurements right here, these two arc measures, will be the same as well, as long as these angles are the same and it's going through the center. Similar circles theorem. All circles are similar. Okay, so if you happen to have two circles that have a different set of radiuses or radii, they're going to be similar. Okay, so in terms you can use proportions in solving, problems with circles. All right, let's go ahead and begin some of the examples. So here is example number 1. Let me fit it in the screen there. All right, find the measure of each arc of circle P, where RT is a diameter, which means that this is a radius and this is the center of the circle. So RS here happens to be this measure right there, which is going to be 110 degrees. So that is going to be the measure of arc RS is going to equal 110 degrees. Please make sure you pay attention to the notation. Okay, now they want me to find out what RTS is. So RTS. So RTS happens to be this right here. Now we do know that the distance from R to T is already 180 degrees. So we need to figure out how much is TS going to be. So because this is supplementary to this, we would have to do 180 minus 110, which is going to give me a central angle of 70, which means that this measure right here is 70. So the measure of RTS is going to be the sum of 180 and 70. So I'm just going to add that up. That's about 250. Okay, so that is 250 degrees. Now the measure of RST is a semicircle, so the measure of RST, whoops, it's got to be a curve, guys. And of course, I need a better eraser. Okay, RST is 180 degrees. So that, ladies and gentlemen, is example number 1. Let's take a look at the next one. So example 1A, B, and C. You can put the same diagram on, for all of those. All right, let's take a look at example number 2. It says, find the measure of each arc. So right from the bat, I can already see that I need to find out what this is going to be. Now remember, the sum of all the degrees here is going to be 360. So I have to subtract 360 from the sum of all of these. So 110 plus 80 plus 40. So I know these two right there is 120. So 360 take away 230. So when I subtract that, that's going to give me 130 degrees. So this right here is going to be 130 degrees. So now I can actually answer all the questions. So find the measure of each arc. GE is going to be the sum of 40 and 80, GE. Okay, now when they want the minor arc, they're probably not going to put this one right here, but if they wanted this one right here, they would have called it GFE. So GE is 120 degrees. Okay, so if you don't know which way they're going, assume that it's the minor arc. Okay, GEF, that's going to be 120 plus 110, which we already know that's 230. So the measure of arc GEF is 230. And the measure of GF, we already know that that's going to be 130. degrees. That looks like a B. All right, so ladies and gentlemen, that is example number 2. So pause the video if you need a little more time to write that down. Example 3. A recent survey asked teenagers whether they would rather meet a musician, an athlete, an actor, an inventor, or another person. The circle graph shows the following results. Find the indicated arc measures. Okay, so we basically have every piece of information that we have. We just need to, answer the question. Okay, so the measure of arc AC, that's arc AC, that would be the minor arc right here. It would be the sum of 108 plus 29. Okay, so when we add those, now I'm feeling lazy. I'm going to use my calculator because I don't want to add my head. Okay, so when I add 108 plus 29, that gives me 137 degrees. Okay, so for B, A, C, D, I would need to add 29. I would add 29, 108, and 83 because AC, ACD is this right here. Okay, so 29 plus 108 plus 83, that gives me 220 degrees. Now for C, they want the measure of arc ADC. So ADC would be 79, 81, and 83. So the sum of 79, 61, and 83. Did I say 81? I probably did. Coffee hasn't kicked in yet. Should have kicked in. It is decaf. All right, 223 degrees. And for D, the measure of arc EBD. Okay, so EBD, that's pretty much everything except 61. So I could add all of these, or I can do 360 minus 61. So I could do this, or I can simply add 79 plus 29 plus 108 plus 83, and I'm going to get exactly the same thing. Okay, so I get 299, and if I were to add up all these, I'm pretty sure I would get the same number. So let me just add them just in case. Yep, got the same number, 299. All right, so that, ladies and gentlemen, is example number 3. Let's take a look at the last example. It says, tell whether the red arcs are congruent. So if you take a look at this right here, and these two red arcs, they are both central angles with a measure of 80 degrees. Okay, so according to the theorem that we just learned, and that is the name, the congruent central angle theorem, CD and EF are going to be congruent. Okay, so the measures of these two, they are going to be congruent. So CD is going to be congruent to EF. Now, in this one, they're definitely not going to be congruent because the radiuses are not even the same. So, not congruent. On the third one, there are two separate circles, but they do have the same radius. And you can tell because of this symbol right there. And they both have 95-degree angles, which means that UV, the arc measure of that, is going to be congruent to YZ. And that, ladies and gentlemen, concludes our lesson for 10.2. Have a great day, and thank you for watching.